This is a video revising statistics and probability for Year 9 5.3 Maths. Okay, so we've got a question. For the given data set, find the mean, median and mode. So these are measures of location. Measures of location. Okay, there's another statistic called the range, and that is the measure of spread. Okay, so let's calculate each of these, and then we'll have a brief discussion about what they mean. Okay, the mean is sometimes written as this, usually referred to as the average, is the sum of all the pieces of data divided by the number of data. So we add up all the values there, 5 plus 2 plus 4 plus 10 plus 6 plus 1 plus 2 plus 9 plus 6, and we divide by the total number 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's do that on the calculator. 5 plus 2 plus 4 plus 10 plus 6 plus 1 plus 2 plus 9 plus 6 divided by 9. Okay, so we get a mean of 5. So the median, we first need to put the data in size order, in ascending order. So I would encourage you to cross out the values as we go along. So we've got a 1, we've got a 2, we've got another 2, we've got a 4, we've got a 5, we've got 2 6s, we've got 9, and we've got a 10. Okay, so we have 9 pieces of data. So 9 is odd. So we use n plus 1 divided by 2. So the position of n plus 1 divided by 2 gives the median. So we've got 9 plus 1 divided by 2 is 5. So the median is 5 spaces along. 1, 2, 3, 4, 5. Median just happens to be 5. Okay, so the median splits the data into 50% either side. So if you can see, we've got 4 either side. So you can think of the median as a pivot which balances the data. Okay, so by the way, if you get an even number, the position of the mean is the average between these two. Okay, so let's go for the mode. It's bimodal. Bimodal, and the modes are 2 and 6. Okay, so the key is to make sure that you can find the median in odd data sets and even data sets. let's have a brief discussion of each of these measures of location, and then we'll have a look at the effects they have on skewed data. Okay, so let's have a look at the mean first. What are the advantages of using the mean? Okay, so mean. Okay, so the mean uses every piece of data Okay, so every item of data. Also, the mean is affected by outliers. The median splits in half. It's not affected by outliers. And let's say something about the mode. The mode is the only measure of location which can be used for categorical data. Of location for categorical data. So, for instance, your favorite color, eye color, the month you were born, so on and so forth. Okay, so these are some of the advantages and limitations of the mean, median, and mode. Let's have a look at the effects each statistic has on skewed data. Okay, that's much easier. Okay, so I always start off with the symmetric data. So symmetric distribution rather means that 50% of the values lie either side of the mean, median, and mode. So the mean, median, and mode are all the same values. Okay, now let's give this data some skew. Okay, so we should probably label this as symmetric. This is a symmetric distribution. And let's give this a positive skew. And let's give this E and negative skew. Okay, so positive skew means that there's a big tail to the right. Negative skew means that there's a tail to the left. Okay, now the mode for each is still going to be the highest value. So this is frequency, and your x-axis is going to be your particular statistic. Now the median, first of all, is the skew has the largest effect on the mean. The values to the right here drag the mean to the right. However, the median is in between the mode and mean for most positively skewed data. Don't forget that the median splits up the graph into 50% either side. Okay, so negatively skewed data has the opposite effect. The mean is dragged to the left, and the median is in the middle. Okay, so a distribution is a function which tells you everything that's happening for every piece of data. Okay, so let's have a look at stem and leaf plots. Okay, so a shop owner has 2 jeans shops. The daily sales in each shop over a 16-day period are monitored and recorded as follows. Draw a back-to-back stem and leaf plot with an interval of 10. Okay, so let's do that then. Okay, let's use the line. Okay, so you can pause the video and have a go at this yourself and then check the answer. Okay, let's go for shop A. Shop B. And we're told to draw a back-to-back stem and leaf plot with an interval of 10. So we're going to go up in 0, 1, 2. And I would encourage you to cross off the values as we go along. They're already in ascending order. So we've got 3, we've got 12, another 12, 13, 14, 14, 15, 15, 21, 22, 24, 24, 24, 26, 27, 28. And the same for shop B. We've got 4, 6, 6, 7, 7, 8, 9, 9. We've got a 10, 12, 13, 14, 14, 16, 17, and 27. Okay, so this is our stem and leaf plot, and we're asked to compare and comment on the differences. Okay, so this is A, B. So let's look at the differences. Shop A has the highest number of daily sales. as the highest, and we can see that here. Shop A has a long list of sales in the 20s. Shop B only has one, which is 27, and sales are between 12 and 28. So we're omitting the 3 because we're calling the 3 an outlier. Okay, shop B has sales between 4 and 17, so we're ignoring this as an outlier. Between 4 and 17, and only one sale of 27. Okay, and that should be enough to get you all the marks. As an extra, let's work out the mean for A and the median for A. So pause the video and have a go at doing those. Okay, so the mean for A, we're going to use this formula. So we're going to add up all the values and divide by the number of values. So we've got 3 plus 12 plus 12 plus 13 and so on. We should get 280 divided by the number, which is 16, and that should give us a mean of 17.5. Now the median should be close to the mean because there's not a huge amount of variation in this data, and we've got clustering, so the mean should be pretty close to the mean. So let's figure out how we're going to work out the mean. So this time we've got an even number of data values. So the position, let's do this in blue, the position is going to be the average between n over 2 and n over 2 plus 1. Okay, so it's going to be the average between 8 and 9. So the 8th position is going to be 1, 2, 3, 4, 5, 6, 7, 8. So 15 plus 21 divided by 2. 15 plus 21 divided by 2. And that gives us 18. So we were right. The median is very close to the mean. Okay, so let's have a quick look at sampling. Okay, so there's some different sampling techniques. Okay, so we've got a census and we've got a sample. and sample. Okay, so the easiest way of thinking about this is the census is the entire population. A sample is part of that population. Okay, so a census uses every unit of the population and is more accurate, but is very expensive. And time consuming. Okay, a sample uses few units of the population. It's quick or quicker than census and is cheaper. Okay, so what are the types of sampling we can use? Okay, so let's list them. Okay, so you need to know these. Okay, there is a random sample. There's a systemic, and there is stratified. Okay, the random sample is sometimes called a simple sample. Okay, it's used for a large population. Each member has the same chance, so members have same chance. And it can be biased. The problem with random sampling is how we randomize the selection of the elements. Okay, so systemic, the population is the same or homogeneous. So pop is the same or homogeneous. So homogeneous means the same. It's evenly sampled. So an example of systemic sampling is we're going to ask everybody between the ages of 20 and 30, or we are going to ask every 20th person who comes into a shop, or we're going to ask all the females. Stratified is where the data is divided into strata. Okay, we recreate the population on a smaller scale. So and let's say one more thing. it's quite complex. So let's go through this again. A random sample is used for large populations. Every member should have the same chance, but there's bias in how we sample. So a example of a random sample could be we ask every member in a train carriage what they thought about the government at that particular time. Systemic, we use particular groups within that population which are the same, i.e. age groups. They could be different sex groups, male or female. They could be different income groups. Stratified is when we recreate the population in a much smaller sample. So for instance, we know that a certain percentage of people in Australia are between the ages of 20 and 30. So we ask, say for instance, it's 20%. So we ask a fifth of our people in our sample what they think to give the value for the 20 to 30 group. It's quite complicated, and bias does occur in stratified random sampling. The larger the sample, the less the bias. Okay, so let's have a look at some questions. Okay, so sampling and types of data. Well, we didn't go over data types. So let's list them very quickly. Okay, so we've got numerical, and we have got categorical. Okay, there's two types of numerical. There is continuous, and there is discrete. Okay, so discrete would be something like shoe size, number of children. So there are finite options. Continuous can take any value, infinite number of values. Okay, so categorical has two types as well. We have ordinal, i.e. ordered data, ordered, and we have nominal. Which is discrete. Okay, so the ordinal data has a hierarchy, i.e. Cane would be an example, a satisfaction table where we rate something 1, 2, 3, 4. Nominal discrete has no hierarchy. So eye color, blood type, so on and so forth. Okay, so pause the video and have a go at doing all these questions, and then I will go through the answers. Okay, so hopefully you've done that now. Okay, so finding the most popular TV program. So that's going to be a sample. This is going to be a census. This is going to be a sample. This is categorical ordinal. This is numerical continuous. This is numerical discrete. And this is categorical ordinal. Okay, so let's have a look at some of the other questions. Okay, stratified sample. Okay, the class consists of 20 girls, 10 boys, 30 pupils altogether. We want a sample of 5. Okay, so the total is 30. So we need to have 5 times 20 out of 30 for the girls, and we need to have 5 times 10 out of 30 for the boys. Okay, so we can 2 times 5 is 10, so we got 10 over 3, so that is 3 1/3. And here we've got 5 over 3, so that gives 1 2/3. So we need to select 3 girls and 1 and 2 boys to give a sample size of 5. Okay, the table shows the number of students in each year group. Total is 750. Jenny is carrying out a survey for her GCSE maths project. She uses a stratified sample of 60 students according to each year group. Okay, so 60. Calculate the number of year 11 students that should be in the sample. Well, the year 11 students are 130 over 750. So we need to multiply our sample by the proportion of group. And that's really important, and that is the same for all questions. So let's do 13 over 75 times 60, and that gives us 10.4. We run down, so 10 people from year 11. Okay, so let's have a look at probability. Okay, so pause the video and have a go at these. First one was list the sample space, so let's do that very quickly. So the sample space is, so that S sample space 1 2 3 3 7. B probability of 3, well, that's going to be 2 over 1 2 3 4 5. C probability not 3, put a little bar on the top. Probability of something not happening is 1 minus the probability that it happens. So that's going to be 1 minus 2/5, which is 3/5. D is 3 or 7. Well, we've got 1 3, 2 3s, and 1 7. So that's going to be 3 over 5. And we've got E, probability of a number which is at least 3. Okay, a number which is at least 3. So that is 3 is at least 3. So is 3, and 7 is at least 3. So we've got 3/5. Okay, that was pretty straightforward. Let's have a look at Venn diagrams. Okay, so construct a Venn diagram for the survey results. A survey of 30 people found that 21 like AFL and 12 like soccer. Also, 7 people like both AFL and soccer, and 4 like neither AFL nor soccer. Okay, pause the video and see if you can do this. Okay, hopefully you've done that now. So let's draw a box for our Venn diagram. Okay, now they've already told us most important information. AFL, soccer. Okay, so we've got 7 people like both AFL and soccer, so the 7 is going to go in the middle. 4 like neither AFL or soccer, so the 4 is going to be in the outside. Now, how do we decide how many people like just AFL? So 21 like just AFL, but within that 21 21 people like AFL, but within that 21 people there are 7 people who also like soccer. So we need to subtract 7, otherwise we would have counted it twice to give 14. The same with soccer. We've got 12 minus 7 is equal to 5. Now we always do a check and add up the original amounts to see if we get 30. Okay, so we got 17, 21, 25, 30. Okay. Now, let's have a go at doing B. So we need the number of people who like AFL or soccer. So the number of people who like AFL or soccer is going to be 14 plus 7 plus 5, which gives 26, or is going to be everything. That's really important because the people who like both also like AFL or soccer. Okay, so the second one, do not like soccer. So the number of people not soccer. So there's two ways you can work this out. I would work out the number of people who do not like soccer are the number of people who do like soccer minus the total, which is 7 plus 5. So that gives 18. So let's have a closer look what we've done now. The number of people who do not like soccer. So the total is 30. And let's subtract the number of people who do like soccer. The number of people who do like soccer are 7 plus 5. Okay, and then finally, like only AFL. Number only A. That's an easy one. That's just going to be 14. Okay, the probabilities. probability A and S. So A and S is always going to be this one. This is A and S. So that's going to be 7 out of the total. So the probability neither AFL nor soccer. So neither AFL or soccer is going to be outside. 4 out of 30, which is 2 out of 15. I'm guessing the last one is going to be the hardest. Probability only soccer. Okay, so only soccer is going to be just this. It's not difficult at all. 5 over 30, which is 1 over 6. Okay, so the important points for these are to remember that or means everything in the Venn diagram. This, and this, and means the intersection. And be careful to realize that we do need to subtract the people who like both from each of these values here. Otherwise, we're counting them twice. Okay, so let's have a look at the two-way table. At a car yard, 24 cars are tested for fuel economy. 18 of the cars run on petrol, 8 cars run on gas, 3 cars run on both petrol and gas. Illustrate the situation using a two-way table. Okay, so let's do that then. So we're going to have a two-way table. Let's do lines. 3 going down. 1, 2, 3. Okay, now all these questions are pretty similar. They're pretty similar. So we need to populate this two-way table. So the first one, we're going to do gas and petrol. Now, we're not told anything else. So we try and populate by doing not gas, not petrol, and we're going to have total and a total here. Now let's put in different colors what we are told. So we're told that 8 cars run on gas. So we know, let's put what we're told in blue. So we're told that there's a total of 8 cars which run on gas. We're told that there's a total of 24, so everything should add up to 24. And we're told that 3 cars run on both. So we can put the 3 there. And what else are we told? A car yard has 24 cars are tested for fuel economy. 18 of the cars run on petrol. So can't we put 18 there? And we can work out now the various values, which I'm going to put in red. Okay, so what do we need to add on to, and it's just as simple as this. Once we get the totals and the other values, we can subtract to find the missing values. So not gas is going to be 18 minus 3, which is 15. We need to add 5 here. we need to add 6 here. So we need to add 1 there, and we're going to get a total of 16. So the most difficult thing here is to fill out these columns. And once we can translate the blue, what we are given, the rest is pretty straightforward. So pause the video and have a go doing the rest. Okay, so let's do B. This is A, by the way. Let's do B. We got do not run on gas. It's the number not gas. Number not gas is 16. The number neither petrol nor gas is 1. Here, not gas, not petrol. Then we have to find some probabilities. So first one, probability of gas is 8 over 24, which is a third. Probability only gas is 5 over 24. Only gas is going to be here. It's going to be in gas and not petrol. And the last one is probability of gas or petrol. So that is going to be 15 plus 5 plus 3 all over 24, which is 23 over 24. So petrol or gas, well, if we're in this region here, there is petrol and gas. Next, we need to find petrol, which is 15, and then 5 is just gas. So another way of doing this is to work out 1 minus probability of neither petrol nor gas. So that is 1 minus 1 over 24, which is that value there. So 24 rather, over 24 minus 1 over 24 is 23 over 24. Okay, so let's have a look at tree diagrams. Pause the video and have a go at doing this. Okay, so let's have a quick go at doing this. So we're going to draw the tree diagrams. So we've got Annabelle, Brody, Chris. If we choose Annabelle, we've got Brody and Chris. If we choose Brody, we've got Annabelle and Chris. If we choose Chris, we've got Annabelle and Brody. Let's do the probabilities then. So we'll get a third chance and a half chance. Okay, let's do the outcomes. So that is Annabelle, Brody, Annabelle, Chris, Brody, Annabelle, Brody, Chris, Chris, Annabelle, and Chris, Brody. Okay, so we've done most of the work now. So list all possible outcomes. That is A. B, find the probability of Annabelle and Brody. So there's 2 ways to do this. There's 2 ways to do this, and I'm going to do the 2 ways. So the first way, I will be looking down here. I've got 1, 2, 3, 4, 5, 6 options. And I tick where I see Annabelle and Brodie. Annabelle and Brodie. Brodie, Annabelle. So that is a third. The second way is to recognize that Annabelle and Brodie is the same as the probability of Annabelle Brodie plus the probability of Brodie Annabelle, which is effectively what we had here. But we can do this without counting the outcomes. The probability of Annabelle is a third times the probability of Brodie is a half, and the same here. A third times a half, which is 1/6 over 1/6, which is a third. Okay, so let's have a look at the second one. Second one is the probability of Chris. So we go down Chris, 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 1, 2, 3, 4 over 6, which is 2/3. And the last one is probability of Chris or Brodie. So we go down and tick where we get either Chris or Brodie, and it's every single one. So that's just going to be the probability of 6 over 6, which is 1. Okay, I hope this makes sense, and good luck, Year 9, for your second assessment.